I've got a problem here with lots of words. Let me give it a read. In a warm climate, a population of rabbits has a changing birth rate modeled by the function b of x, which is equal to b times e to the 0.1x minus x, where x is the number of days since observation started and b of x is approximately the number of baby rabbits born per day. Approximately how many rabbits were born during the first 3 weeks of observations? Wow, there's a lot to take in there. Okay, but what I can get is that there is a rate here of rabbits born per day, which has a formula, and we want a total number of rabbits born over time. And I know that if I integrate a rate, it should give me an amount, the amount that it changes by. So the change in the number of rabbits should be the integral of the rate of change. Okay, so it should be the total rabbits born should be an integral of the birth rate. Let's see, first 3 weeks would be from time equals 0 to time equals 21, because there's 21 days in 3 weeks. Okay, I just want to draw a graph of the function to make sure I know what's going on here. So I'm going to jump over to GeoGebra and do that. Here's GeoGebra. And b of x is 5e to the power of 0.1x minus x. Okay, so that's what the function looks like. The birth rate starts at 5, and then it goes lower and lower, so less rabbits are born per day, and then it increases again until like there's, what, about 20 born per day at end of day 21. Okay, wow. Right, and so the area under here would be the total number of rabbits born, which is going to be quite a lot, I reckon. Well, let me calculate it. So I'll go from 0 to 21, and then I'm just a bit ahead of myself, actually. I haven't actually written down what the formula is. So 0 to 21, the formula is 5e to the 0.1x minus x dx. Okay, so now I can do this. So I'm going to have to integrate this. So the 5 is multiplied on, so it will still be there. The e to the power of anything will be still e to the power of thing, but because there's a constant multiplied by the x, I'm going to have to divide by that constant. And then the x, this is like a power of x, so x to the power of 1, the power will go up by 1, and I'll divide by the new power. Okay, and now I have to sub in both the 21 and the 0 and subtract the two answers. But just let me do a little calculation. 5 divided by 0.1 is 50 minus a half of x squared, 0 to 21. Okay, so I'll put in what I get with 21 and I'll put in what I get with 0 and I'll subtract them. So 50 e to the power of 0.1 times 21 minus a half of 21 squared. It's interesting. And 50 e to the power of 0.1 times 0 minus a half times 0 squared. Okay. Now, always sub it in properly for both of them, because sometimes when you put in 0, the answer doesn't work out to be 0. So it's really important to do them both. Okay, so 50, not to the power of e, 50e to the 2.1 minus a half of 441 minus 50 times, now e to the 0 is 1, and that's 0. Okay, 50e to the 2.1 minus 20.5 minus 50. Okay, I reckon it's time to get a calculator to help me figure that out. Let's see. 50 times e to the power of 2.1 minus 220.5 minus 50. 137.8. So we've got, well, approximately 138 rabbits. It was only a model anyway, so I reckon we can just round off. So approx 138 rabbits born. Okay. Cool. We've got our answer.